Hello everyone, today's problem was submitted by a viewer. It says, a sequence of numbers a0, a1, a2 is such that an plus 1 minus an is equal to b r to the n, where r is not equal to 1. Show that an can be expressed in the form p plus q r to the n, where p and q are independent of n, and find the values of p and q in terms of a0, b, and r. Okay, so the first thing that I note here is that the difference between any two terms is a geometric sequence. So I'm going to call this dn. And this simply says, so a naught is a naught. a1 is equal to a naught plus d naught, right? That's from rearranging. If I let n be equal to 0, that's a 0, that's a 0, and that's a 1. And I've just rearranged this. Ignore that for now. And then a2 is equal to a1 plus d1, which is a0. So remember that a1 is a0 plus d0. Okay, and if we continue this, it's pretty easy to see that in general, an plus 1 is equal to a0 plus the sum dk, so k goes from 0 to n. And so what I want to do, we're asked to write an like this somehow. I have a formula for dk given by this, and because these numbers are a geometric sequence, this is just a geometric series which we have an expression for. Okay, so I'm just going to continue with this here. Okay, so the only thing I'm not sure about here is I can never remember if this should be an n or an n plus 1. I think in this case it is n because I'm starting at the index of 0. So for now, we'll put a quick question mark there, but let's, I'm going to try and derive the appropriate formula. Okay, so it should be n plus 1, apparently. All right, so now, because we're asked in the question, we're asked for a formula not for an plus 1, but a formula for an. So I'm just going to rewrite this as an is equal to a0 plus b 1 minus r to the n over 1 minus r. And at this point, it's really just about simplifying this. So I have an is equal to a0 plus b 1 minus r to the n over 1 minus r. So if I write this as a0 plus b over 1 minus r, I'll put that in parentheses, minus b over 1 minus r, also in parentheses, times r to the n. Then if I compare this to the expression we're asked about, p is equal to a0 plus b over 1 minus r, and q is equal to negative b over 1 minus r. Yeah, there were basically two keys here for this question. The first is recognizing, the first thing that popped out to me was the geometric sequence sort of embedded in this other sequence of numbers. And, you know, the sequence an itself is not geometric, but the difference between two terms is geometric. And then realizing that if you're given an expression for the difference between any two terms, then you can use that to extract the value of any one term is just going to be essentially a sum of all those differences. And because, again, we knew the differences themselves were geometric, this is just a geometric series, which is pretty basic. Although I didn't have the formulas memorized, if you know how to derive them, you never really have to memorize them. I hope I did that correctly. I mean, maybe there's like some simple weird index off by one thing going on here, but the general idea for this question is pretty much this. That's a nice submission. Thanks everyone for watching.